What's up, you freaking geniuses? So in this video, I'm going to teach you how to rationalize the denominator by multiplying by the conjugate. All right, so we're going to do a few examples, and I'm going to start with this one over here because it's a little bit different. I want to make sure you don't confuse this type of problem with one like this. All right, so here we have 7 over 2 times the square root of 3, and then down here we have 7 over 2 minus the square root of 3, okay? So here you can see we're multiplying together 2 times the square root of 3, okay? So here, in order to rationalize the denominator, you would just multiply the top and the bottom by the square root of 3, okay? And then to simplify this, just multiplying straight across, 7 times the square root of 3 is equal to 7 root 3, and then that's over. The square root of 3 times the square root of 3 is equal to just 3, so that's equal to just 3, and then we're still multiplying by 2 over here, right? So 2 times 3 in the denominator. So then this would be equal to 7 root 3 over 6. Okay, and just to clarify what I did here, the square root of 3 times the square root of 3 is equal to just 3, right? So to make that make sense, let's use a couple numbers we know. So if we did the square root of 4 times the square root of 4, this would be equal to just 4, because the square root of 4 is equal to 2, right? So here we really just have 2 times 2, which is equal to 4, okay? So same thing here, square root of 3 times the square root of 3 is equal to just 3, or the square root of 100 times the square root of 100 is equal to just 100, okay? But in any case, I just want to clarify that to rationalize the denominator over here, we multiplied by just the square root, right? Just the radical, okay? But down here, it's going to be a little bit different. Okay, we didn't multiply the top by 2 root 3 and the bottom by 2 root 3, right? Because that's what's down here. It was just the radical, okay? Now here in this other example, it's going to be different. So here, we're not multiplying, we're subtracting. So if you're ever adding or subtracting two numbers like this, with one of them being the radical, in order to rationalize this denominator, you need to multiply by the conjugate. Okay, so that means we're going to multiply this whole thing on the top and the bottom. The only difference being you're going to flip the sign. Okay, so since here we're subtracting, on top we're going to have 2 plus the square root of 3, and on the bottom we're also going to multiply by 2 plus the square root of 3. Okay, so then again, just multiplying straight across, 7 times 2 plus the square root of 3, right? So we have 7 times 2 plus the square root of 3 on top. And then on the bottom, we have this, right? So 2 minus the square root of 3 times 2 plus the square root of 3. Okay, so here we actually have to FOIL. So again, FOIL stands for first, outer, inner, last. Okay, so first, we're going to do 2 times 2, which is equal to 4. And then we're going to do outer, so 2 times the square root of 3 is equal to 2 times the square root of 3, and it's positive, right? So 2 root 3. And then we're going to do inner, so 2 times negative root 3 is going to be negative 2 root 3. And then we're going to do last. So the square root of 3 times the square root of 3 is just 3, right? But we have a negative times a positive, which is equal to a negative, right? So this is going to be negative 3. Okay, so then we can keep simplifying this. So on top, we can distribute the 7 into the parentheses. So 7 times 2 is equal to 14. And then 7 times positive root 3 is equal to positive 7 root 3. And then that's over the bottom over here. So we can simplify some stuff, right? So here we have positive 2 root 3 minus 2 root 3. So that just equals 0. So then on the bottom, we really just have 4 minus 3, which is equal to 1. Okay, so 14 plus 7 root 3 divided by 1. Well, anything divided by 1 is just itself, right? So then this is equal to just 14 plus 7 root 3, right? So that's your final answer. All right, last one here. So we have 12 over the square root of 2 plus the square root of 7. So again, we're going to multiply by the conjugate, right? So on top, we're going to multiply by the square root of 2 minus the square root of 7. And same thing on the bottom, right? Square root of 2 minus the square root of 7, right? So then simplifying this, on top we have 12 times the square root of 2 minus the square root of 7. And on the bottom, again, we need to FOIL. You're going to have to FOIL a lot with these problems. So we're going to do the square root of 2 times the square root of 2. That's equal to just 2. Square root of 2 times negative square root of 7 is equal to the negative square root of 2 times 7, which is equal to 14. Okay, and then here, same thing, the square root of 7 times the square root of 2 is equal to the square root of 14. And then these are both positive, right? So we're going to have plus the square root of 14. And then lastly, positive root 7 times negative root 7 is equal to negative 7, right? So minus 7. Okay, so then simplifying this further, on top, again, we can distribute this 12 in here. So 12 times the square root of 2 is equal to 12 root 2. Okay, so 12 root 2. And then 12 times negative root 7 is equal to negative 12 root 7. Right? And then on the bottom, you can see we have a negative square root of 14 and a positive square root of 14. So those cancel out, go to 0. So on the bottom, we're just left with 2 minus 7, which is equal to negative 5. Okay, now here there's nothing we can simplify, so then this would just be your final answer. 12 root 2 minus 12 root 7 all over negative 5. So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below.